Nice to meet you.
We're doing these mini interviews with Zeta Alpha to capture a little bit the atmosphere in NeurIPS and talk about people's work, what they see, what they find interesting.
Yeah.
So tell us a bit about yourself.
Yeah, okay, so I'm a research scientist at Google. I work on AI for mathematics, but in general I'm using language models or build on top of language models to improve the reasoning capabilities of these models these days.
So what brought you to NeurIPS?
Oh, I had a couple of papers here, and I want to basically meet my old friends. This is actually
It's the most social event for years.
Yeah,
right?
I mean, it's actually, I think last year when I attended the in-person conference, that was already like 4 years ago, before COVID. So, it's
Great way to meet people.
Old friends, many old friends.
And so I'm curious, how do you see this space evolving with this prompt engineering and reasoning, chain of thought, all these things? Seems that it's advancing very rapidly. What's your view on that?
Yeah, so I think prompt engineering has been pretty successful for the last year or so. Especially we see for, as you said, like chain of thought, that kind of very human-like way of reasoning has been proved pretty successful. We have been using it, for example, in our recent Minerva work, where we try to solve.
Yeah, it's a very cool paper. It was one of the highlights of our year.
Yeah, we try to solve some high school mathematical competition problems, and this model even got to grades that are higher than like the average high school students. So I think it has been pretty successful, and I guess in sort of more in the future, I guess there are two ways we can go down. One is we see more interesting algorithms that do some kind of automatic prompt engineering. I mean, especially there's some recent paper called language models or prompt engineers or something where they
are human level prompt engineers.
Exactly. Yeah. So that's so that kind of work sort of gives one direction of how we can potentially improve prompt engineering. I guess in general, you can think of maybe like prompt engineering is one way to potentially even get some interesting data from the model and
introspection or something like that.
Right, and then potentially some good data can be then used to again train the model themselves. And so this is sort of along with the second line of work that we are doing some kind of like bootstrap reasoning with reasoning. So this is the star work that we also present here.
Yeah.
And we believe that maybe in the not near future, we get a very strong model that potentially you don't need to do much effort with the specific prompts you like to do the kind of engineering with the model.
Yeah.
So that's another way. And I think I guess that the two different ways are still pretty meaningful, and I'm very looking forward to them. Yeah.
And so you're fundamentally interested in mathematical reasoning, right?
Yes.
So to what extent would you say that these models are really doing mathematical reasoning, or more kind of a shallow approximation of the thing that kind of looks good enough for high school mathematics, maybe?
Yeah, very good question. I think what we learned is that if you throw a lot of good data to these models are basically pretty good at imitating what humans do. For mathematics, the model seems to be able to pick up like the kind of patterns in human data and is able to sort of write similarly as human solutions. But how much is it actually doing mathematical reasoning? I think, or maybe let's say the other question is like, how do we go beyond this, right? Like, I think my vision is that just like playing, other kind of games or so, like you don't want to just imitate other people do. You want to also
understand
play the game.
Underlying principles.
Exactly,
right?
Play the game yourself, understand the rules of the game yourself, and this is why I have been mostly pushing for building some kind of mathematical environment or framework for these models to interact with. It's not like I'm building them. Okay, so I guess the mathematical environment is these kind of formal proof systems that can automatically check the proofs or sort of give you the signals of whether your conjecture or your proof is correct or not. So essentially, this is almost like a simulated environment that allows you to play games.
Math dojo.
Yeah, exactly. But the problem is that like in order to play this game, you have to write in formal code. So like formal math. That's what and so essentially, there's a sort of a translation process from the usual kind of natural language mathematics that we're taught or like maybe let's say very common on the internet that the model is, for example, Minerva is trained on, and you need to somehow translate that into some formal code so that the formal system can understand. And this process is what we call as the auto-formalization. And this is what I've been mainly working on. And I hope that once we have this kind of bridge between the natural language mathematics and the formal mathematics, we can eventually train the model to do real mathematical reasoning, so that the model can sort of understand what is actually the sort of the what's actually true, what is false. Yeah.
So if I can ask something, like I feel like what you were talking about before about the kind of like the next step with the Minerva and having some sort of environment to sample from. I feel like it's interesting. It's something that we have highlighted before. This whole space of, it sounds to me a little bit like language models and reinforcement learning, kind of like coming together, and like having these language models as we know them are kind of like you can understand them as being trained on imitation learning kind of setting, and like the reinforcement learning setting where you kind of sample interactively. Do you have any specific papers at NeurIPS that you would like to highlight that kind of work on that direction?
Yeah, I think the bootstrapping reasoning with reasoning, the STAR paper is I think to me is a very good first step towards this direction, where we just, in some sense, we're using RL or like the very basic algorithm reinforce to train these models to be better at certain tasks. So that, for example, in one of the tasks, common question answering, we use this STAR algorithm or the RL algorithm to train the model to be as good as a model that's 60 times larger. Actually, sorry, 30 times larger. So it's the GPT-J actually gets to a performance that's almost close to GPT-3. That is. So I think these kind of methods are. I'm very looking forward to them. So I was talking about, yes, I think the question about like mathematical environments in general. The question is like, how do you evaluate the model in some sense? Like what is the feedback signal? In the case of STAR, we use a very simple mechanism of like just matching the final ground truth label, final answer to determine the reward function. Like if it matches exactly, then you get a reward of 1. If not, then you get a reward of 0. But that reward function probably is somewhat tacky because it doesn't really care about the intermediate solution. Whereas with auto-formalization of these proof assistants, you can actually check the correctness of the whole proof. So the whole rationale or the whole argumentation of the proof. And that's what I'm looking forward to. And I guess along these lines, we also have one paper in a main conference, auto-formalization with large language models, that shows like a proof of concept of like how do you translate natural language mathematics into formal math. And there's also another poster at Math AI Workshop.
Yeah, that's on Friday, right, or Saturday?
I think it's on December the 3rd, so that's on Saturday. Yes, yes. So we had a paper that translate or formalized the entire natural language proof into a formal proof, so that eventually, I think, in a near-term future, we can then, let's say, take Minerva solution and directly verify it in a proof assistant, and this is what I see as the potential future of how do you do reinforcement. This is how you get like the reward function, the reward evaluation for improvement.
And then you would, with that you can kind of solve this like credit assignment problem. Like what reasoning step is
exactly.
Like responsible for the reward.
Yes. That's right. Yes. So this is the real exciting part of what we're working on.
So to go back to the social side, you said NeurIPS is a great opportunity to meet friends. Any tips you have for people at the conference, for socials or parties, or
I think
New Orleans sightseeing or music?
Yeah, I was actually doing like a bike ride this morning around the city with two of my friends, and I recommend
with these
that.
funny little blue bikes, or
no, actually that's
you had a real bike.
No, we rent the bike in one of the bike store, rental bike, and we went to the city park. We did like a tour around the city. It was very nice. I think I would recommend that. We tried some local food here. Many very good seafood restaurants nearby, and in terms of social, I guess. I would recommend just hanging around, where there are many people, and I guess you just you definitely can meet some interesting people to talk to. Yeah.
Right. Thanks.
Yeah. Thank you. Yeah.